So folks, today, Sunday, it's the 15th, I've just done one church service and so I've got 10 minutes before lunch. So we'll make a start on the next customer. This is Dave's. He's bought it off eBay and it's been sent direct to me, which saves some post. And this has come with one of those awful power mics which have no place on FM radios because they're all speech processed, so you're just making it worse. Oh, here it is. It's so nicotine that there we are. We have an Altai power mic, and we won't be. Oh my goodness! It's even got a Roger bleed. You can actually use it as a standard dynamic mic, it says. But we're going to use the switch. I just don't enter into this kind of stuff. These mics were £6.99 when ordinary mics were £9.99. So you can imagine how good they are. Just check this battery roughly. Well, it's got 8.25 volts in it, so it needs replacing, but we'll switch this to standard, like that, put that back together, and I'll just check it works, but we'll be running all the work on this radio with the standard replacement mic. Just open it up, just in case there's something nasty inside. February 82 one, so it's got self tappers in, which is wrong. So you know, why has it got self tappers? How many golden screwdrivers have been inside it? I've not put my soldering iron on, which was rather remiss of me. I can't see anything dodgy in that, to be honest. It smells of damp garage rather than nicotine. Check that the shut up, that's that. I'll just check that this is getting to the stage where I'm having to check aerial sockets aren't opened up. I actually wanted to change our base aerial. That's not this base aerial, it's the one on our Midland base station. We've got Mark here this weekend, and so if Mr. Chippy turns up, it may be possible to do that. I want to do a before and after video. So what I'm hoping to do is just have time to write down how well this is working. Then I will have to have lunch and we'll see if we've got time afterwards. It's another harvest festival. We're still at that time of year with the churches. Won't get, you know, we do these power connectors, we do the leads, offer them on eBay, but you know, postage keeps going up and it's frustrating. You try and do people a good deal and then postage goes up. 40 pence is it gone? No, 30 pence. It's gone from 115 to 145 for second class large for the little jiffy bags. You know, don't mess about, do they? You know, just add like 25% onto it. Right, our standard replacement mic is wide cybernet for these, even though they're a Maxon set. Power it up at 13.8 volts. Switch it on, and it's on at 19. Switch to PA. Testing 1 2. Testing 1 2 3 4 5 5 4 3 2 1. So that's a good start. Just see if the transmit light works. It actually works. So that's something which can fail on any of the Maxon sets. Don't know whether they were overdriven or just a bit dodgy quality. Right, picture in picture on. Let's key it up. I'll put it on the 3-watt scale. We're on channel 20. Bangs across. We're doing 3.3 watts on channel 20. Channel 40. 3.2 watts. Channel 1, let's guess. Shall we say 3.4? No, we won't. How bizarre. 3.2. Doesn't have low power. Should have had, but it didn't have. And the transmit current, if we go back to channel 20, is 1.105 amps. We're not doing the VCO. Now, frequency, I'm just going to take that with a pinch of salt because the test gear's only been on, and the test gear has a half-hour stabilisation time. This isn't because I'm using a 1983 test instrument. You've got a crystal oven, which is its reference, and this goes the same with whether it's 1970 or whether it's brand new. You've got to wait for this thing to come up to temperature. I know we have the Schlumberger, whatever it is. We had one of those at Nottingham Radio, and it was 6 months was the best stability was achieved at, so you didn't want to be turning that off. What was I doing apart from talking? Frequency. So it's 27099. It's well within. What I'll do, I'm going to bring it up to 2779125 if I can, and then we can. What's that? Oh, it's the speaker lead. And then we'll look at it again later after the instruments are stabilised. I couldn't even say that. There we go. Now we can look at the frequency and put the signal generator on frequency instead of compromising. So we're on the signal generator now, just tuning it in. Now as we get onto the spot on frequency, it's actually sounding worse than when it's low. So it tells me the IF's a bit out. But it doesn't matter, let's have a look at what the cyanide meter's got to say. So anything better than 1 microvolt is acceptable on this chassis. And this set is doing 0.72, which is already decent. For 10 dB, 0.66, and if it will do 20, it's 1.6. Tight squelch. I like it to be 100 microvolts. Let's go to the attenuator. There's no hard and fast rule on this, but that's my experience, 100 microvolts, and it isn't coming in. So let's see when it comes in. Well, guess what? It never comes in. So on full squelch, the radio never opens. So at tight squelch, never opens. That's a clever setting, isn't it? So let's do the opposite and see how sensitive it is. We'll turn the squelch down on the radio, set threshold on the radio, and then switch the signal generator back from standby. It's parked at 0.3 of a microvolt. So let's see where it is. It's actually 0.62, which is absolutely fine. What you don't want is a squelch above 2 microvolts. Some of those team sets are like that, and so they chop around scratchy corner. Good squelch is vital on an FM radio. So 100 microvolts on the signal generator. Let's see what the meter reads. It's bang on S9, absolutely bang on. And on this set, it's possibly, I think it's adjustable because it's the later one. So it is 100 microvolts. The meter lamp's lit. PA works. And let's look on transmit and see what the meter reads. We know the set's doing 3.3 watts. And it actually reads about 4. So to be honest, it's about, as far as the meter goes, it's spot on. The sockets work. The potentiometers work. The switch works because there's only one, it's PA. We haven't tested the speaker, so that's got through a load of tick boxes. This looks like it could well just be a retuning test. It makes a change from having trade repairs, which are ones the dealers can't fix, which gives me a bit of thinking, doesn't it? It's nice to get a straightforward, genuine set. So, let's try and get that in the screen, and that as well. And see if we can turn up the power to 4 watts. So go to the main meter and let's see how we go. But to make sure it's in the centre of its peak, so it's peaking in the centre where I'm turning it and not to one edge. So I need to drop it and find that peak which is there. To be honest, it was already right. So the next one will hopefully bring the power up a bit, and then the final one does the final one does the final adjustment. What a silly thing to say. That feels like it's at the end of its travel. So we're at 3.4 watts. Let's see if we can bring a bit more with this one. 3.6. And they want you to fiddle, believe it or not, they want you to fiddle with these fixed coils, believe it or not. I think it's stupid, but they do. Make sure it's placed right. Not playing at coil stretching, we're playing at placement. We'll have one more go at this one. So that's now 4.4, so I now need to drop it with this one, and it's going to be down for that drop. By doing it like this, we should have it within 0.1 on the band edges. So we're spot on the 4 watts. So let's have a look. Channel 40. I'm going to find where I put my pen. How can I lose that? Oh, it's there. So 4 watts. I can't write on it because there's a wire underneath. Channel 40 is 3.95. And I bet channel 1 is just slightly over. It is. About 4.02. Transmit current on channel 20 is now 1.087. So we've gone from 3.3 watts to 4 watts, and it's now drawing less current than it was before because it's tuned right. Yes, Mr. Tango. Now we'll do the deviation. As I've said recently, the deviation meter on this Marconi test set needs some capacitors changing, so it's not always reliable. So we'll just go over to the test set behind me, which is reliable. and we'll just see where the deviation is on that one. Do I have to change glasses? No, I don't. Wow. 4.5 at the moment, so that needs to come down, folks. There we go. Wow. That's now right. So I'll turn that test set off. We'll go back to the Marconi one. Out of interest, we'll see what this one says today. Sometimes it's right, sometimes it isn't. So let's have a look. Wow, it's about right. See, it's 2.2. So it was 4.5. Exclamation marks, now 2.2 to 2.5. And we'll see where the meter is. So on transmit, now it's doing 4 watts instead of 3.3. It says it's doing 5. So I just need to pop that down a fraction to make it a bit more true. Remember, this is only relevant into a dummy load. Once you put it on an aerial, it could bang across, it could read 2. It's still doing 4 watts. It's relative to SWR, etc. So we've set that. So although it was right before, of course we've turned the power up from 3.3 to 4 watts, so it's no longer right. So there's our little thing. So I'll take a break, have lunch, and see if we've got time when I come back. Otherwise, it'll be much later this evening. There we are, I've gobbled up my dinner, and let's have a look at the receive on this set. So we'll put the oscilloscope on, put 100 microvolts on the signal generator. Turn up for a meaningful... I'm not showing that, am I? That's it. And as I said many times, the Maxon chassis can be prone to the detector going out. Except on this set where it's absolutely spot on. So let's see whether we can improve the sensitivity. So we'll go over to the cyanide meter. And we'll go for about 4 dB, so it's as little a signal as possible, so you're not saturating the receiver. Start with there. We have an improvement. So we'll drop the signal a little, back to 4 dB. Well, a very slight improvement. That was spot on. And that was spot on. We haven't got a coil there. On some sets there's a coil there. Probably higher up in the range ones. So that's it. So a little tiny bit, we've got an IF which was very slightly out, and we got one of the front end very slightly out. So let's see whether we've got a better sensitivity now. So back to 12 dB, and we've now got 0.64. Yeah. For 10 dB, 0.57. And if it will do 20, what it did before, not quite 1. It is 1.4. That is only to do with noise. Right, squelch, we will need to adjust that. So squelch to full. I've got the signal generator set to 100 microvolts. So let's pop that inset picture onto the attenuator. So 100, 0, and we need to adjust the squelch preset till we hear the receiver receiving. Well, that's the plan. Okay, let's put 300 on. There we go. So I've got that to absolute minimum. So let's see what that is. It's 275 microvolts. And at the sensitive end, park the signal generator at 0.3, set the squelch threshold on the radio, see where it comes in. It's now 0.47. So much as I like that to be 100, there isn't a hard and fast rule on that. But to have the squelch so it never ever opened is silly. I'm just going to check the radio still on frequency, whether it's drifted. So let's go back to camera 2. Key up. 2779132. So as it wasn't warmed up, I'd overshot it slightly. Not that it would have mattered, but we'll just drop that back. So that means I got 79099. It would have been probably 79104 or something like that. But there we are. That's done. So we need to set the S meter. It was correct before, but of course we've improved this receiver. And there we are. It's still bang on the 9, so it doesn't need adjustment. Had it needed adjusting, it's going to be the... Sometimes there's a preset there, and there is in this case. I'll just prove it is that by adjusting it. And it is. Sometimes there isn't one at all, and it's preset at the factory to 50 microvolts. So it's a bit generous. Sometimes there's one on the meter, depending which version it is. This is the later build from February '82. So there we are done. It's nicely working. So I'll put the soldering iron back on, and we'll put the lid on. So it's quite simply a retune and test. We'll do an on-the-air test later. That's the wrong speaker. No idea what that's come out of. You don't normally find the factory speakers failing, so that does surprise me. The thing is, you can't get square speakers very easily at all. End up paying about £15–17 for them, whereas you can get the round ones for £5. This gentleman's got quite a collection of sets, so he knows where there's a square speaker lurking if he needs one. The big question is, does the speaker work? Sounds fine. Don't know what we're going to do screw wise, because I'm not putting the self tappers back because they're wrong. Let's see what silverish screws we've got on the bench and hope the threads aren't ruined. Can rethread them. So that's one. I can also worry about this tomorrow when I probably have the shortest time. I can just find two to get myself by. There's another one which will do. Put that in the opposite corner. Straight away, there's another one. So we're only one short now, aren't we? Remember, 3 screws in, but they were all self-tappers. But unlike most sets, they're not black screws. Well, Mark sorted me out a pot of screws here. There we go. So now we'll plug it into the aerial. It's on the Antron 99 without ground plane kit. Turn the soldering iron off from the test equipment, save some electricity. May as well turn that off. See where they're all having the Sunday lunch. 1 Nana Roger. Well, it seems a nice set. So I look forward to doing the on-the-air test with Mr. Chippy later on. Thanks for watching Midland 2001 Precision Series. One thing I ought to just do is we'll just listen to the audio. I know it's difficult. Squelch. Testing 1 2. Oh, I'm on the wrong channel. Testing 1 2. Testing 1 2. 1 2 3 4 5. So we know we've got audio on that. We'll just plug in the daft mic. Testing 1 2. Testing 1 2. 1 2 1 2. 1 2 1 2. 1 2 1 2. So there's something wrong with that. Sounds like a knackered lead. Good. Catch you on the air test later on.